All right, welcome to lesson 3 for Unit 1. This is all about algebraic expressions. All right, don't forget to write your name and today's date. Okay, so algebraic expressions, which you hopefully have seen before, is basically when we have a pattern, we sometimes just use symbols to help represent that pattern. So we can use a variable to represent a number in an expression. And typically for variables, we just use any letter. So we'll often see X, N, Y, Z, really any letter you want. Okay, so for example, we've got a few expressions here, and we want to write them as mathematical expressions. So an example here is 3 more than a number. We have to be kind of careful when we go from words into mathematical expressions. So this one's pretty straightforward. 3 more than a number. So maybe I think of that as a number is n, and I want 3 more than that, so I'm going to do n plus 3. And that would be correct. You might also be thinking, well, 3 more than a number is 3 more than a number. And in this case, you'd also be correct. Both of these are just fine. They mean the exact same thing. N plus 3 and 3 plus n, there is no difference. But addition's pretty straightforward. We're going to see in a second that there's other cases where it's not quite so simple. Okay, let's try this next one. 7 times a number. So for my number, I'm going to use n. So 7 times a number, which is n. Now, this is fine, and you can write it like this. That's totally acceptable. But the thing is that using this multiplication sign sometimes gets confusing if you remember that we also use x as a variable. And so what mathematicians do is we have an alternate way of writing that. Sometimes you'll see this written as 7 times, they'll just do a little dot, n. So those actually mean the exact same thing. It turns out, though, that mathematicians are kind of notoriously lazy, and if they can get away with not writing something, then they will. And so there's another way to write this, and that is to just write 7n. And that is the preferred way of writing this expression. 7 times the number, just write 7 with the variable right beside it. 7n, 7x, 7y, whatever it is. Any of these are correct, and if you use those, you're not wrong. It's just that you want to get in the habit of using this last one here. Okay. So let's look at something a little bit trickier. 8 less than a number. Well, you might be looking at this and saying, okay, that looks to me 8 less than a number. I'm going to think of that as being 8 less than a number. But you might also think, well, hold on a second, maybe it's a number and I'm going to minus 8. And we're not really sure which one of these is correct. The thing to recognize is that those are not the same thing. With addition, it didn't matter which order we add them in. N plus 3 is the same as 3 plus n. But with subtraction, it's not the same thing. 8 minus n is not the same thing as n minus 8. So we have to be really careful how we read this. It's 8 less than a number, which means we take a number and we want to take 8 away from it, which means this is our correct interpretation. This one is wrong. Okay, we have to be really careful. Subtraction is sort of, when you read it, it's almost the opposite of the way you read it. Okay, a number divided by 20. So a number divided by 20. A number, I'll just use n, and then I'm going to write that as divided by 20. Now again, this is correct, and there's nothing wrong with writing it this way. I'm just going to show you another way of writing the same thing, which is to say n, and we can write our divided by sign as a line, kind of like a fraction, and I know you guys love fractions. So n divided by 20. Those are the same thing. And again, there's nothing wrong with using either one. You do, though, want to kind of get used to this form here, okay, as you move on to math. That one's going to be a little more common, and so you'll see that we start to lose this little divided sign. We often write it as a kind of like a fraction. Okay, when we're dealing with expressions, take a look at this expression right here, 5k plus 2. There's different parts to that expression, okay? And the 5 in that expression is something that we call the coefficient. So the number that is attached to the variable, or right in front of the variable, we call the coefficient. The 2 is called the constant. And the k is our variable. Okay? So, let's try going the other way around. Let's try going from an algebraic expression and writing it into words. All right, my first example here, 5k plus 2. Well, I guess I could just think of this as 5 times a number plus 2. Our next one here, 32 minus 4x. This one's a little bit trickier because of that subtraction there. And so the way we would say this is we would say 4 times a number less than 32. And our last example here, we've got 12 plus n over 2. And what we can think of that as 12 plus a number. And that little line we just learned means divided by. Divided by 2. Okay, sometimes we have a particular number in mind for our variable. And so if we take that number and substitute it into our expression, what we're doing, we say, is we are evaluating our expression. And so we're finding the value of that expression when we have that particular variable, of that particular number. Okay, so we're going to evaluate the following expressions here. So for example, find 5k plus 2, evaluate that expression when k is equal to 3. Now before we do that though, we have to remember that there's something called our order of operations. Okay, and when we carry out operations, we have to do it in a particular order. Okay, a way to help you remember your order of operations is something called BEDMAS. Okay, so BEDMAS is just gonna give us our rules for how we're gonna progress through evaluating something. BEDMAS is an acronym and it stands for the following. It stands for brackets, exponents, division, multiplication, addition, and subtraction. Now, I'll just put a little asterisk beside exponents here because technically you're not going to do exponents this year, but you might run into them pretty soon. So it's good to know that that's where that sort of slots in terms of the order. Okay, so let's go back and take a look at our expression. We want to evaluate each expression for the given variable. So what we do is we know we want to find when k equals 3 what this whole expression is. So we take that 3 and we're going to substitute it in there where we see k. So this is 5 times k, it becomes 5 times 3 plus 2. Okay, and now here's where it's really important to go over and think about our BEDMAS in terms of solving. Which of these steps are we going to do first? Well, the first thing we're going to do, if we follow down, brackets, exponents, division, multiplication. So multiplication comes before addition, so we're going to do this step first. So 5 times 3 is 15, and then I've still got my plus 2 here, and then I can do this step next. And 15 plus 2 is 17, and I've got my final answer. Okay. All right, let's try another example here. We've got 32 minus 4x, and we want to solve that for when x is equal to 5. So that's going to be 32 minus 4 times 5. And again, think about your BEDMAS steps. Going down our list, brackets, exponents, division, multiplication comes before subtraction. So we're actually going to do this step first, even though it sort of comes up later in our expression. So we've got 4 times 5 is 20, and we still have 32 minus, because that hasn't been done yet, so we'll do this step next. 32 minus 20 is 12, and that's our final answer. All right, that's it for now. Do your recap, and then you're all done.